On top of the screen right now is the two responses or two answers to the introduction example where we wrote factored form and standard form that correlated to that picture. So I just have them rewritten on top of the screen because I'm going to use, for the next 5 examples, I'm going to use these pieces for our division problems. So I just wanted them to kind of be handy as a point of reference. So once we divide, using long division, we could kind of compare our answer to the problem we built it from. So this way, we're just going to work on one solid example over and over in different ways, like different approaches to the division. Okay, if we're dividing this cubic polynomial of 4 terms by this linear binomial, again, this is just stored up here from the previous example, x minus 2 is the thing that goes outside of the division, and this goes on the inside, x to the third plus 2x squared minus 5x and minus 6. There were 2 words that you guys learned in the division unit in elementary school that started with the letter D that described these 2 things. Do you remember what they were called? One was a dividend. Divisor. Yeah, good. So this is the divisor. I always would remember the divisor would need to wear a visor because it doesn't have a roof over its head and the sun's in his eyes. And then the dividend is end side, like inside, get it? Stupid, I know. Inside your division symbol, okay? When we do these, you also want to make sure they're in standard form, that all the like terms are combined, and if anything's missing, that you put in what we call a placeholder, but we'll see that in a later example. Okay, ready, Freddies? Let's go. To do long division of polynomials, it's going to be very similar to that conversation we had with 145 divided by 3. We're going to start with the first term, like how Isabel said to try the 1. We're going to start with this first term, but the thing that's a little different is we're worrying about dividing it by this first term. So on the side, we're going to divide line leader of the inside by the line leader of the outside. This also ties us back all the way to lesson 1, properties of exponents. I hope that we could all kind of think of this as division or simplifying. What is x to the third over x? That's just x to the second. Good. Now, this same circular motion is going to happen for the problem. Where do I write x to the second? With polynomial division, your answers end up kind of being in columns, sort of when I combine like terms when I was just doing even this over here, how I kept my work in columns to make combining like terms easier. You'll see that same trend happens here. So x squared, I'm going to write right up here, x squared. What did you do next? So remember, it always comes back to the same fundamentals, and just take your time with it, even if it seems awkward. What did you do next after you had something written up top? By? Sure, perfect. So x squared, I'm going to multiply by this divisor. So I'm going to get x to the, so right here, I divided the leading term inside, in this case, x to the third, to start my division problem. I divided that by my leading term on the outside, which was x, and I just did that division on the side. So this is the thing, you want it to go here, right? Like on that. So the reason it doesn't is, kind of think of this like a train. The train, you have the main engine car that drives, and then you have all the little passenger cars that are tugging along, right? So here's the engine, and here's the engine. Passenger car, there's just one, but this one has 3. So when we're dividing, you have this little binomial, right? Two pieces, but we focus on the engine part. And the two pieces, we're going to do these two. Then we're going to have two more and two more. So you can only divide in pairs with little binomials. So you're going to do these two. Then we're going to do those two underneath, and then those two. So you'll get 1, 2, 3 answers here. So the way it lines up is these two divide with these two. We start the answer right there. Oh, sorry, this thing pops up on this screen. I'm sorry. I guess because I have like the free trial of this. Oh my God. All right, but valid question. There are going to be teachers or tutors. I know a lot of you guys, you work with someone after school, or you have a friend or a tutor, and they do get messy, and they do that. And I used to do that. But then when I started teaching and realizing I was responsible for like other people doing it right, I realized like not everybody can hold 100 steps in their head, right? So by doing it this way, you basically can't really mess up. You'll just be better off in the end for everybody. All right, so now we multiply that here, and it's going to go underneath right there, right? X squared times x is x to the third, and then x squared times negative 2 is negative 2x squared. And do you see it, again, lines up in the right columns? After you wrote the piece underneath in long division 4th grade style, what did you do next? We wrote down a number underneath there. What did you do next in 4th grade style division? You could just shout it out if you think you know. Good, but here's the thing you're going to hear me say 100 times. Ready? That would be horrible if you wrote that. Just this little minus, right? Why is that horrible? You're subtracting a whole, go ahead. Exactly, and if you just stick a minus, oh my gosh, everything gets to be a mess. So this is what I'm going to say every time, the same way. Ready? I always say parentheses, minus sign, underline, cancel. You'll hear me say it a million times. Parentheses, minus sign, underline, cancel. Parentheses, minus sign, underline, cancel. If these two things don't cancel, you're not doing it right. You already messed up. They should cancel. The parentheses are really showing us how we're subtracting off that whole quantity that Estelle was just mentioning, right? Like it's going to have to distribute. My next piece of advice, though. If you've ever done this before, or if you've seen it, or you kind of have the idea of it, I understand that some of you are going to take your pen or pencil and you're going to go right here and change it to a plus sign, right? So you're like, oh, minus negative. The problem with that is it's like all in the same pen or pencil. You get halfway through the problem, you don't remember if you distributed it or not. You go back, you redistribute it, you change it, you mess it up. So what I do every time, I will never physically distribute it. I will do it in my head every time. So that cancels. Can you subtract this minus this in your head and tell me what to write right here? What do we get? You can just shout out. Go ahead. Good. Everyone see why it's 4x squared? And I never distribute it like physically inside. I didn't write over my work. It makes it easier to go back because you have 2x squared, but minus negative. So I never will write it on top of this because if you realize you messed up in the middle of the problem and you go back and try to fix it, but you already wrote over it, it's going to be a disaster. But if you know you never write on top of it, you know what the original work is every time. After you subtract, what happens next? Right, you bring the next, normally it's just a digit, but here we're going to bring the next term down. So it's the same root process, like the skeleton of the procedure is the same. It has a little extra pizzazz to it because we're dealing with polynomials, obviously, not numbers, but same idea, right? So here, who's the new line leader? Right. Now I got to divide the line leader on the inside, which was that 4x squared, but we still divide it by the line leader on the outside, which is x. And what do I get? 4x. Good. So when I divide, I just think about it as simplifying, right? You're just reducing or simplifying this little baby fraction. 4x, it's positive, so plus 4x. Where do I write that? Over here. So if we think back to the beginning, liter divided by liter, we got this. Watch where the finger goes around the paper, right? We put it here, multiply it here, write it here, subtract, get that, bring down, repeat. Goes up, plus 4x. What do I do with that? Multiply it, and we're going to write it down there. So what's 4x times x minus 2? You get?
4x squared minus 8x.
Nice. 4x squared minus 8x, and then I say that same phrase every time. Parentheses, minus sign, underline, cancel. Go ahead.
So you only have to match the first number up with that to the bottom two, right? Just not the second one?
Yeah, only the first part cancels. The other part you subtract and use that left. And sometimes it will accidentally be 0, not accidentally, but coincidentally be a 0x or 0x squared, and you just treat it like a 2x squared or a 4x squared. Just use that 0x squared in the work. You cancel the first part, that goes away. Anything left over carries, and if this is a binomial, it makes us our new binomial to keep going. Okay? Now, this is the part where if people are going to mess up in the problem, it's here every time because they don't do this subtraction correctly. Negative 5x minus negative 8x. So think it through. Don't be impulsive here. This is where people just want to blurt and write things down. So on the count of 3, tell me what you think goes here. 1, 2, 3.
3x.
Whee! 3x, yay. But people accidentally want to put negative 13, right? So make sure you take your time. Minus negative means plus. Now, we're really almost done. What do we do next? Right, that minus 6 is going to come right down here. We're looping around again. Liter here, 3x. Divided by the liter there, x. What does that become? Once you get a constant to write down, you know you're on your last roundabout. So plus 3 goes right here. Multiply it, we get 3x minus 6. The big phrase, parentheses, minus sign, underline, cancel. Now, here I'm going to write the number, even though I know you might want to be also cancel. I cross out, yay. But negative 6 minus negative 6, as a number, I could write 0. Whatever number you get right here in this last step, see you're at the end of your division, everything lines up. Constants, all linear, all quadratic. It helps you know you're doing it correctly, right? All cubic. Once you get to this number, whatever that number is represents what? Exactly, it's the remainder. If your remainder is 0, or if you don't have a remainder, what does that tell you about your division? No, it tells you that these are factors, right? When you have no remainder, it just means it divides evenly, right? So you can just try, for homework, guys, just one example, just the next one. If you want to go a little further, you can, but it's exactly the same process. It will also have a remainder of 0, okay? Kind of get it? A little bit? I got one nod. Anyone who participated, if you'd like a sticker, from my sticker book. Isabel wants a sticker? I know some of you guys do. Don't be shy. I should end this recording.
Wait, is it like you take it off and you immediately can stick it on something?
You can cut it out if you want to save it.
I don't really like to stick.
I have to stop this recording.
Thank you, Ms. Thomas.
Do you need a sticker, anyone? Participators? I have the other book too, the little pink one, I think, right? There should be two. But I have to just, sorry people listening to this recording.